Hello and welcome to a session on how to write clean code. My name is Karandeep Malik, and today I'm going to share with you certain tips regarding writing clean and maintainable code in Java. The tips and tricks that are being shared in the session have been taken from the famous book called Clean Code by Robert C. Martin, or also famously known as Uncle Bob. The importance of writing clean code is to have good code quality. So let's first define what is code quality. Now let's assume that there is a code reviewer who's reviewing your code and he or she comes across a lot of what the fuck moments while reviewing your code, then definitely this is not a good code and it is actually a bad code, and it is important that this code should be refactored and written into a form which can be easily understood and which can be easily followed by somebody who's looking at it. So coming up next are certain tips that I'm going to share with you which will help you to write code which is easily readable, easily understood, and easily maintainable. The first tip that I'm going to share with you is regarding naming conventions. So it is important that the names that you are choosing for either classes or variables or functions should be chosen quite carefully and should be meaningful. And they should actually convey the purpose about why they have been selected. And these names should be easy to remember. And you should not be required to actually write a separate command to explain the purpose of these variables, functions, or classes. Now let's look at the code on the left hand side. It defines a function print which has got certain variables I, N, T1, T2, T3. Now just by looking at this function name or at the variables, we neither understand at first glance that what this function does or what its various variables represent. Whereas if you clearly look at the code on the right hand side, you would see that the name of the function is print Fibonacci numbers, which actually tells us that this function prints the Fibonacci series of numbers, and the variable names have been chosen quite carefully as they represent the role that they are playing in printing the Fibonacci numbers. The next tip that I have to share with you is regarding choosing names at the appropriate level of abstraction. Now let's assume you're defining the interface for a model. Now, if you look at the left-hand side of the code, there's a interface defined called modem, and then there is a function called dial, which takes a string phone number. Then it has a function to disconnect, another function to send data, another function to receive data, and another function to get connected phone number. Now, while this modem interface might help or kind of fit in certain conditions, but if you look at the level of abstraction, this modem interface actually assumes that all modems accept some kind of phone number to actually dial in, which is a wrong assumption because if you talk about modems in general, or if you talk about a generic definition of modem, a modem may dial a number to actually connect to a particular ISP, or it might also send some signals to actually connect to the ISP. So assuming that a modem will always dial a number is actually a wrong assumption and is at the wrong level of abstraction. So on the other hand, if you look at the interface on the right hand side, it actually does not assume every modem to connect through a phone number, and it is actually assumes that there should be a connection locator which will help to establish the connection, and that is and another function called get connected locator which assumes that connected locator to be returned when the function is called. So it is very much essential that all the interfaces or functions are defined at the right level of abstraction. The next tip that I have to share with you is regarding choosing the names. That's very essential that when you're choosing the names for a function or variable, they should be easily pronounceable and should be meaningful. Now let's take an example that we need to define a class customer which requires two variables. One variable represents the date of generation of the customer or the date when he was added to the system. And the second variable defines the date of modification, that is when the customer record was last modified. And both these variables have the format year, month, date, hour, minute, second. So if you look at the code on the left hand side, it defines both the variables. Now, while the person who has defined the names for the customer class variables on the left hand side might have good intentions, but if you look at the variables names, they do not look any, they do not convey any meaning. I mean, just by looking at the variables, you cannot understand what they actually present. Whereas if you look at the class customer on the right hand side, it defines these variables as the generation timestamp and the modification timestamp, which actually clearly convey what is the purpose behind defining these variables. Moving on to the next step, it is also recommended that you should not use member prefixes. So earlier it was a habit among all the programmers that whenever you're defining a member variable in a particular class, you would use the member prefix m underscore for all the variables that belong to the class level. Now, this is actually something which is not required, and the reason behind that is it is expected that your class should be small enough that it should have only a few variables, and you do not need to explicitly write m underscore to distinguish them with other variables. Now, one should actually may want to question this particular tip, because if you're not writing m underscore, then how would you actually differentiate a member variable with other variables? Now, the easy way to do that is, and it's something which is already a part of all the editing environments or the GUI environments that are being provided for code editing. They actually tend to highlight or colorize members to make them distinct from other variables. So while writing code, it would be very easy to identify which variable is a member variable and which is not a member variable just by the color of the variable. So if you look at the variable on the, or sorry, the class on the left hand side, which is part, it defines a variable m underscore desc, and in the function set name, it is actually setting this property. Whereas if you look at the right hand side code, it defines the variable as description, which actually clearly describes the reason or the role of the variable in the class. And then there's a very well defined function called set description, which sets this property. The next tip that I have to share with you is about naming in a way that the the side the side effects of the particular function or the variable should be clearly communicated. Now, names should actually describe everything that a function, variable, or class does, and the side effects that it causes should never be hidden, and the name should actually describe that. Now, let's look at the function defined here, get object output stream. If you look carefully at the code which is there in this function first checks if the variable OOS is null, then it actually assigns a new instance of object output stream to this variable and then returns it. But if the variable OOS is not null, then it simply returns that variable. If you look at the name that has been given to this function, that is get object output stream, it does not convey to us that there is an inside check which actually creates a new instance if the variable is not assigned any value. So a better naming for this function would be to call it create or return object output stream instead of get object output stream, because create or return object output stream clearly defines the side effects that the function has. The next tip for naming convention is when you are actually choosing a name, the name should actually firstly come from the solution domain, and secondly, if not present in solution domain, then it comes should come from the problem domain. The names chosen for variables, functions, classes should either be from solution domain, the reason being the people who are actually going to deal with the code are programmers. The solution domain is computer science, and whatever the means the name setter chooses that chosen, that is the CS terms or computer science algorithm names or computer science pattern names, these are familiar to all the programmers, and just by looking at the name they would be able to understand what this particular function or variable or class is doing. Now let's assume that if there is no computer science term associated with what the function or class or variable is doing, then then the other strategy to follow is use the name from the problem domain. So the advantage about using a name from a problem domain is the programmer who actually maintains your code can actually ask a domain expert and understand the meaning behind the variable chosen or the function defined. Also, it is important that when you are actually choosing names, you should always pick one word to define a concept. Or what I'm trying to say here is you should have consistency. So you should actually pick one word for one abstract concept and stick with it. Now let's say if your function actually tries to return some value, then instead of calling it fetch in one class, retrieve in another, and get in probably the third class, it's better to define either fetch in all the three classes or retrieve in all the three classes or get in all the three classes. So it is usually beneficial to follow a consistent pattern while naming. My next step to you is about comments. The comments should never have inappropriate information. One such information that is usually associated with comments is the change histories. That is, who changed this. That is, some people tend to write or maintain history about who changed what in the code. Now, in this modern era, when we have got very good source control tools which can easily track who did what change in the code, you do not need to explicitly maintain a change history. So this is some kind of an inappropriate information. Something that could be appropriate while writing comments could be, say, if there is something that is left to be done, or there is some kind of a to do information that you want to include, then that is something which is appropriate and can be included. Or if you want to sometimes mention the intent behind choosing a particular algorithm or technique, then comments play a useful role. Also, it is important to avoid redundant comments. Now, what is a redundant comment? A redundant comment is a comment which describes code that adequately describes itself. For example, let's say I++, and you are writing a comment increment I for it. Now, just by looking in I++, a person would understand that it increments the value of I. Writing an explicit comment to say that it is doing incrementing the value of I does not convey anything extra. So this is something which is redundant information. Also, let's say if you've defined a constructor which does not take any argument, then writing a comment which defines it as a default constructor also does not make much sense. Similarly, if you look at the code on the right hand side, there are two variables, name and version defined. The comments say the comment for the first variable is the name, and the comment for the second variable is the version. Now, just the name and the version do not convey anything extra from the meaning that is already being conveyed by the variable names. So this is something unnecessary. Also, some people even usually follow this coding convention that they define a Java doc for a private API that does not say more than or even less than the function signature. Now let's look at the code defined at the bottom. It says the comment says there is one parameter cell request of the which the function accepts. It returns cell response and it throws managed component exception. Now, if you look at the definition of the function, all these three things that have been defined by the comment above are clearly visible just by looking at the function definition. So it does not convey anything extra and is something which is redundant. So we should actually avoid writing redundant comments and increasing the lines of code. Also, it is a good practice to actually delete any commented out code. Now, some developers actually leave stretches of code that are commented out. They think that they would actually, in some later point in time, they would actually come back and probably change this code or may require to reuse this code. Now, this is usually is not a good practice because what happens is when the developer actually leaves the organization, the code continues to be a part of the code base, and other programmers or coders who come after him think that probably this code is something important and that's why it has been commented out and has not been deleted. And even they do not actually delete it and assume that it might be needed or somebody has actually plans for it. And such garbage code kind of tends to remain in the code base for long. Also, there's a practice among certain programmers to write closing brace comments. That is, after closing braces, they have a habit of writing special comments to tell which particular block of code is closed by this closing brace. That is whether it is a while or it is a for or it is a if or it is else. Now, in all the modern UIs, we have this feature of automatically indenting the code in a way that the code under a particular block is well formatted and it is very easy to make out which particular part of code belongs to which particular block, and the indentation itself should be able to clearly highlight that a closing brace that has been used is for which particular block of code. Some people might say that my block of code is very big and it is easy to lose the track of where it is closing. So my suggestion to such people would be it is better to actually shorten your function instead of writing such closing brace comments. The next tip that I have for you is one should always try to explain yourself in code rather than in comments. Now let's see, if you look at the code on the left hand side, there's a comment which says check to see if the employee is eligible for full benefits. And then there is some logic written behind it. Now just by reading the logic that is defined by the code, it is difficult to make out what it does. So there is an explicit comment that has been used to define its purpose. Instead, if you look at the code on the right hand side, The logic has actually been transferred into a function, and the function has been named in a way that it defines that this function actually checks if the employee is eligible for full benefits. So usually moving such code into a function with a well explained name is a better strategy than explicitly writing a code command to explain what it does. My next tip is about functions. Now, while writing functions, a lot of people have this habit of passing too many arguments to the function. Well, the book Clean Code recommends that functions should always have small number of arguments. The best strategy is not to have any argument, and the second best is one, then third best is two, and maximum it should have three arguments. If you're using more than three arguments, then it is very questionable and it should be avoided with prejudice. A lot of people say that, for example, I'm calling an API and the API returns 10 parameters, so I can't do anything about it. Well, to be honest, the better solution in a way is not to add, instead of adding more parameters of functions, you should actually change the API to into multiple pieces, and each API should actually accept only a few parameters. Also, a great tip about functions is functions should always be small and do only one thing. Functions should either do something or answer something, but they should not do both. So either a function should change the state of an object or it should return some information about that object. Doing both often leads to confusion. Let's see that with an example. Now, if you look at the code public boolean set function, it actually accepts a string attribute and a string value. Now this function actually sets the value of a named attribute and returns true if it is successful and false if no such attribute exists. Now let's say if this function is being used in the following format in which, that is used in an if statement, then just by looking at this code, you can easily understand that whether this function is actually setting the value of username to Uncle Bob, or whether it is actually checking if the value of username is Uncle Bob or not. So this kind of confusion can be easily avoided by not complicating the signature of the method. And such things should be divided into multiple functions for checking. Also, it is important to delete dead functions. Sometimes during refactoring, it happens that you would be working on a piece of code and you would have defined a function, and while refactoring, it it results that it results in a situation that there are certain functions that are now not being called anywhere in the code. Modern UI editors are very good in this, and they clearly show the functions that are not being called anywhere, thereby attracting your attention towards this fact. And such that functions should always be deleted from the function and should not remain as a part of the function. Also, I would like to share that passing output arguments to a function is actually a bad practice. In normal readability, a developer always expects that all arguments that are passed to a function are input arguments. So you should avoid passing any output argument to a function. And if you want to actually change the state of the object, it should be done by a modifier of the object. The next rule that I want to share with you is the step down rule, and this is something about how the code should be arranged. So when you're writing functions, the code should be arranged in a way that it should read like a top down narrative. So we want every function to be followed by those at the next level of abstraction so that we can read the program descending one level of abstraction at a time as we read down the list of functions. And this particular rule is called as the step down rule. Also, when it comes to functions, you should always prefer to throw exceptions instead of returning error codes. If you look at the code on the left hand side, it actually what it does is first is it tries to delete a page. If the deletion of the page was successful, then it tries to delete the reference of the page from the registry. Then it tries to delete the key which represents the page from the config keys. Now, if you write such code using error codes, then it causes a lot of nesting and it makes the code a lot messier. But if you look at the same code written in a different style on the right hand side, all these three functions, delete page, registry, and config keys dot delete key, they all throw an exception if they are not successful. And you can actually catch that exceptions and log the message as to why deletion of the page was not successful. Also, it is beneficial to actually separate try catch code from actual processing. So if you look at the code on the left hand side, there's a try function that is defined. There's a try block that is defined and in which a function delete page is being called. Then a function registry.delete reference is being called, and if there's an exception, then it is being called in the catch block. Instead, what you could do is you could actually define a single line delete page and all references as a function in the try block, and it contains the all the code which actually talks about the logic, and then this entire function would actually throw a single exception which can be caught and acted upon preceding by the subsequent catch block, and any error that has been raised due to the exception that was thrown from the function is being caught and logged. So if you will look clearly, the logic of the function is being separated into delete page and all references, and the catching of the function and subsequent action is being handled in log error function. So both have been clearly separated. Now, a tip about formatting is when you are actually writing lines of code, your each line should be at max 80 to 100 characters long. 80 is the best and 100 should be the max. Anything beyond that than that is actually difficult for a person to read. And also nowadays in static code checkers like Sonar, lines with more than 100 characters are simply raised as a smell, and they kind of reject the build of the code on that basis. Also regarding formatting of the code, horizontal openness and density should be always taken into care. We use horizontal white space to actually associate things that are strongly related and associate things that are more weakly related. Now let's consider the following function, measure line. If you see all the function parameters do not have any kind of extra spacing between the the function opening parenthesis, but they do have horizontal spacing between different parameters. So the horizontal spacing between different parameters tells that they are different, and and similarly the lack in space between the opening parenthesis of the function and the parameter tells that they are related concepts. So concepts that are related should have zero or very less horizontal spacing, and concepts which are actually different should have enough spacing to kind of give a feel that they are two different underlying concepts. Similarly, regarding member variable alignment, earlier it was a common practice to align variables, member variables of a class in the as described in the left hand side of the code that is being defined. But a much better way of defining or formatting member variables is being defined by the right hand side, and that should be preferred. Now I would like to share tips about exception handling. Exception handling. Now, whenever you are actually trying to throw an exception in a code, it is always better to throw unchecked exceptions. Now, the reason behind that is throwing a checked exception will actually lead to adding throws clause to each function that calls your function. That is, if you are not handling it, or there is no try catch to handle the exception. And it will also lead to the compilation of all dependent code in the upper layers and also in the libs that are calling this function and throwing this exception. So you should always try to throw unchecked exceptions instead of checked exceptions. Regarding exceptions, it is also important to provide necessary context. That is, you should create informative error messages and pass them along with your exceptions so that whenever they are caught or kind of they are logged, it should be mentioned. It can be easily mentioned that what was the operation that actually led to the failure and what was the reason behind that failure. So if you're logging such an information, then this becomes at most necessary. Also, it is important that when you're defining exception classes, they should be defined in terms of caller needs. For example, a file reader code that cannot find a file or cannot open a file, or the file is improperly formatted, or the file does not have access permission, can throw one common exceptions from all places, like say file read failure exception, instead of writing a separate exception in for all the cases. Although you would be easily able to differentiate the cause of failure by the error message, which will be different while the same exception is thrown from different places. In Java, it is very important that when you are facing an exception, you should not return null. The number one cause of failure of Java programs is null pointer exception. So if you look at the code on the left hand side, what it does is it tries to get the employees, and if there are no employees, it returns null. This is not a good practice. And instead of following this practice, a better approach is suggested by the code on the right hand side, which says if there are no employees, then return an collection.empty list. So you're not returning null, but a collection which has got no elements, which is a better way of communicating the fact that there were no employees that were found. If you code in this way, then you minimize the chance of null pointer exceptions. My next tip is about writing effective tests. So I would like to talk about learning tests here. Now, before using any new third-party library, you should actually write tests to check the functionality of the library that you would be using. Now, these tests are something which actually give you a confidence that if there is something that breaks in this library, these tests would be able to quickly figure out that the behavior in the library has been changed. And these tests will call regression to actually tell you beforehand that there is going to be a problem in your main code just because the third party library underwent certain changes. So these tests not only help you to learn how to use the library effectively while you are experimenting with it, but also helps you to keep your production code safe from regressions. Also about tests, one thing is very important, that you should always follow the test first approach. That is, you should always write tests first for every piece of production code that you scribe and test only one condition per test unless they are interrelated. This will always ensure that your production code is always covered with tests and any regression due to underlying library or different part of code is easily detected. Writing tests first is a very good technique in the sense later in the stage, if you are trying to refactor your code, you can be totally you can totally depend on that. If there is any functionality that you're going to break, it will be easily picked up by the underlying tests, and you would be and it will be easily detected, and you can actually fix it before you make it as part of your production code. Also, it is recommended that one should write clean tests. If you look at the test case written on the left hand side, and if you compare it with the test case on the right hand side, it is quite visible that the common part of things that were happening on the left hand side have been cleanly encapsulated inside functions on the right hand side, and that the the code on the right hand side is much cleaner than how it looks on the left hand side. Also, when you're writing tests, your test should actually follow the first principle. The first principle says that your test should be fast, that is, they should run quickly. The I of the first says that your test should be independent. That is, the test should not be dependent on each other, and one test should not set up the conditions for the next test. You should be able to run each test independently and run the tests in any order you like. The R of the first says that your tests should be repeatable. That is, if you have written tests, then should be repeatable in any environment, whether it is production or QA or in your own laptop. Also, the test should be self-validating. That is, the test should always have a Boolean output, that is either they pass or they fail, and should not and you should not have to actually go and read through a log file to see whether your tests actually passed or failed. Also, the T in first actually presents the test should be written in a timely fashion. That is, unit test should be written just before the production code, and a passing unit test should clearly mention that the production code is correct. Also, it is important that while writing tests, you should actually test the boundary condition. That is, you should not only test the happy path or the most obvious failure path, but you should also test the boundary conditions around the code. According to research, it is said that most of the bugs are located are co-located. So you should exhaustively test near bugs. It is said that bugs tend to congregate. So when you find a bug in a function, it is wise to do an exhaustive test of that function. And you might actually end up finding another bug and might actually be able to fix that one too. Also, always use the coverage tool while writing tests. Coverage tool reports gaps in your testing strategy. That is, it clearly tells you which modules or classes or functions are insufficiently tested, or there are no test cases for certain parts of code. Most IDs actually give you a visual indication, making lines that are covered in green and those that are uncovered in red. And that makes it easy for you to actually find out whether there is some interstate code present in your production code. Also, you should always write tests for trivial or the happy path, because in methodologies like agile, where there is as less documentation as possible approach followed, it is important that your test itself become the documentation for your code. So your tests should be written in a way that their documentation value is higher than their cost to produce them. Now I'd like to share some tips about classes. So classes should always be simple, small, and have a single responsibility. If you look at the code on the left hand side, it defines a God class. A God class is a class which has got too many responsibilities. If you look at the class on the left hand side called Super Dashboard, it gets you customer language path, sets the system config path, gets the system config document, gets the open source state, get confined state, gets major version number, gets minor version number, gets build number, and so on. So it has got a lot of responsibilities. But on the other side, if you look at the code on the right hand side, it has the same God class has been divided into smaller classes, and it has been divided in such a way that each class has got just one responsibility. It could have multiple functions, but just one responsibility. Also, it is usually recommended that when you're defining classes, they should have a very high cohesion. Classes should always have a small number of instance variables. In general, the more variables a method manipulates, the more cohesive that method is to its class. And a class in which each variable is used by each method is maximally cohesive. But actually, in practical use cases, maximum cohesibility is not achievable. But still, your focus should be to have as high cohesion as possible. Now, some miscellaneous tips. The first step is to use enums instead of constant ends. Since Java 5 enums have been added to the language, so use them. So earlier we had a strategy that we would use the trick of having public static final ends to actually represent constants. But while doing so, the meaning of the ends gets lost, and just by looking at the constant, you're not able to make out what it actually represents. Instead of that, you could actually use an enum. The meaning of enums cannot be lost because they belong to an enumeration which is named, and by the name itself, you would be able to understand what this particular thing represents. Also, it is recommended that when you are actually it is recommended that you should actually avoid long import lists by using wildcards. So let's say if you're using two or more classes from a package, then you should import the whole package with import package dot star instead of actually importing each and every class from that package, because having long import lists creates a problem that it is difficult to follow from where this particular variable or class is coming. Long lists of imports are daunting to the reader, and we don't want to actually clutter up the tops of our modules with 80 lines of imports. So rather, it is better to have imports be written in a more concise manner